Hello everyone, my name is Naveen Vasisht and today I am going to discuss about the assignment given in data science subjects. So here we start. Describe the concept of hypothesis space in machine learning. Explain the algorithm. Find S, find a hypothesis, find S for the following. This is the given table. Concept of hypothesis. In ML, hypothesis space is the set of all possible hypotheses that a learning algorithm can choose from. The goal of learning is to find the best hypothesis from the space that fits the training data. Example, if an instance has five attributes and each attribute can be any value or question mark, then the hypothesis space contains all the combination of these values. So find S algorithm. Find S is a supervised learning algorithm used for learning conjunctive hypothesis from positive examples only. The steps. Initialize hypothesis H to most specific hypothesis. H is 5555. For each positive training example, compare with if attribute values differ, generalize by replacing with question mark. Ignore all negative examples. Final H is equals to most specific hypothesis that fits all positive examples. Apply find S on given training set. This is the training data set. Initial hypothesis H is 555. First positive example Japan Honda Blue 1980 economy. H is this, and second positive example will be Japan Toyota Blue 1990 economy. And compare with this. So H is equals to Japan question mark Blue question mark economy. Third positive example will be Japan Honda while 1980 economy. Compare with this attribute H example new H final hypothesis H is equals to Japan question mark economy. Question 3. Explain the purpose of training test and validation sets in machine learning. What is cross validation and how does it differ from a simple train validation test plate? Training set used to train the model. The model learns patterns and relationship from this data. Validation set used to tune hyperparameters and select the best model during training. Test set used after the model is completely trained. It gives an unbiased evaluation of how well the final model performs on unseen data. What is cross validation? Cross validation is a technique where data sets difference between train validation and cross validation. Train validation data is split one and cross validation data is split k times. And train validation performance may vary depending on split and cross validation most reliable since every part of data is used for it. Train validation faster because model trains only once and cross validation slower because model train k times. Train validation is suitable for large data sets and cross validation is suitable for small data sets. Question 5. Discuss the importance of dimensionality reduction in ML. Compare it and contrast feature extraction and feature selection as to appropriate dimensionality reduction and provide examples of technique used for each approach. Importance of dimensionality reduction. It reduces the number of input features, it removes noise and irrelevant data, it makes models faster and easier to train, it helps avoid overfitting, it improves visualization when data has many features. Second, feature extraction. It creates new feature from the original ones. The new feature are combination or transformation of the old feature. Example techniques, PCALD, autoencoder. Feature selection. It selects the most important feature from the original set. No new feature are created, only useful ones are kept. Example techniques. Filter methods like chi-square test and correlation. Wrapper methods like forward selection and RFE embedded methods like lasso. Difference. Feature extraction changes the feature into a new form. Feature selection keeps the original feature but may remove unnecessary ones. Question number 6. Define overfitting and underfitting in the context of ML and model. Describe how these issues can be identified and list strategies to prevent or mitigate them. Overfitting. The model learns the training data too well, including noise. It performs well on training data but poorly on test data. How to identify high training accuracy but low test accuracy and ways to prevent is like use more training data, use regularization like L1 and L2, use simpler models, use dropout in neural networks, use cross validation. Underfitting. The model is too simple and fails to learn pattern. It performs poorly on training data and test data. How to identify low training accuracy and low test accuracy, ways to prevent. Use a more complex model, train for more epochs, add more useful feature, reduce regularization. Question number 7. Differentiate logistic regression and linear regression on the basis of hypothesis parameter and cost function. Now gradient descent algorithm is used to optimize the parameter. Linear regression, logistic regression. Hypothesis function h of theta of x is equals to theta to the power x. And in logistic regression, h of theta of x is equals to 1 upon 1 plus e to the power of x. Sigmoid function. Types of problem in linear regression used for regression problems. In logistic regression is used for classification problems. Output in linear regression will be real numbers and output in logistic regression will be probability of belonging to a class. Parameter in linear regression weights of theta 0, theta 1, theta n. And in logistic regression same weight but interpreted as affecting probability. Cost function linear regression mean squared error MSE j of theta is equals to 1 by 2m summation of h of theta of x minus y square. Log loss corosotropy j of theta is equals to minus of 1 by m summation of y log h theta of x plus 1 minus y log of 1 minus h theta of x. Decision boundaries linear regression straight line and logistic a curve. Range of hypothesis in linear regression minus infinity to plus infinity and logistic regression 0 to 1. How gradient descent optimizes the parameter gradient descent theta is equals to theta minus alpha alpha delta j divided by delta of theta where alpha is learning rate. So here we need to write a Python code to implement logistic regression and linear regression for every method, compute and display the implemented models, evaluation measures and such as accuracy and other value different and functions RMSE and R2 score. We need here libraries like scikit-learn and NumPy and matplotlib and others. We will import datasets here and by applying these all inbuilt functions data underscore LR and we will train here X train, Y train, then we will linear regression put into model underscore ala, then fit it and predict it using it storing it in this variable. Then square root of fill rate gill RMSE to us, root mean squared error and R2 square, and we will print all these. Now we will use load breast underscore cancer function in this data log and x log y log data. Then we will train it again. Then logistic regression will put fit it, then predict it, then storing here. Then we will print all these required outputs. Here, one-hot encoding question for this data set. So, one-hot encoding converts the categorical values like apple, mango, orange into binary 0, 1 column. Each row has one in the column representing the category and L0. So, the fruit column apple 100, mango 0, orange 001. So, the fruit apple, fruit mango, fruit orange, value fruit and price. Here we will make other columns for each. Thank you to all to watch till here. Hope you got understand all concepts and all.